Demonstration of our project quality of service for multimedia using SDN. To demonstrate this, we first require a virtual network which can be created using Mininet. So we open the terminal and we create it using the following command, which is this command. As you can see, it creates a linear topology network having 3 hosts and 3 switches, S1, S2, S3, and hosts H1, H2, and H3. Each host is connected to the corresponding switch. Different XTerm terminals are created for each of the components created in the network. Now, the first thing to do is to configure the switches to use OpenFlow protocol version 1.3. This can be done by using the following command in all the 3 switches. Now after this, we now configure the IP addresses of the 3 hosts to give them our required IP addresses. First, we delete the by default given IP addresses by this command. And then now we add our required IP address. The same thing needs to be done for the remaining 2 hosts. Configuration of the hosts and the switches, we now start executing the RU controller. RU is the SDN controller which we are using in this project. So to start the controller, we have to use the command RU manager ru.app.restrouter. As you can see, the controller has been started. The execution of the RU controller, separate routers are created for each of the switches. Now the first thing to do is to set the addresses for each of these routers. This can be done by using REST API's post command. As there are a lot of post commands to be executed, we have written all of them in a script whose contents are as follows. As you can see, there are a lot of post commands, uh, and we can execute it by simply mentioning the file name. As you can see, all the commands have been successful. Executing the script, the IP addresses of each of the router has been set. Now we have to register default gateway for each of the hosts present in the network. This can be done by going to the external terminal of the corresponding host. For example, here it is the host h1, and executing the following command, which is IP route add default via the corresponding IP address, which is here 172.16.20.1, and we have to perform this for each of the for the remaining hosts. The default gateway for each of the hosts, we have to now set the default route for each of the routers. This is again done by using the post command of REST API. For this, we have written a script whose content is as follows. As you can see, these four post commands comprise the configuration of default route of each of the routers. We can execute it similar to the previous script. As you can see, all of the commands have been successful. Configuring the RU controller and the routers, we are now ready to test our network. Now, to represent a real world situation, we need to generate some artificial traffic into the network. This is done using Ostinato. Ostinato is a tool used to generate artificial traffic into the network and is used for network analysis. In our case, we are going to generate the traffic from H3 towards H2. For this, we go to host 3's external terminal and write Ostinato. As you can see, Ostinato has been opened. Now, uh, as you can see here, it has detected H3's port, which is H3ETH0. Now we can edit the stream as per our need. Now here we require the source and destination host's MAC address. This can be obtained by using the ifconfig command. Hence, for example, in case of host 3, we write ifconfig, and as we can see, we get the entire detail of host 3. As we can see here, it has the MAC address, all zeros except the last one as 3. We can put that here in the source, and similarly for host 2 we will have all zeros at the end 2. Now we have to mention the IP addresses of the source and the destination. The IP addresses as mentioned previously of host 3 and host 2 are as follows. Now we can change the number of packets as our wish. So I am giving a large number. Also for packets per second, I am giving a large number to create a lot of traffic. Click apply, and then we can start the transmission. As we can see, transmission has been started, and a lot many packets are being sent. After generating artificial traffic using Ostinato, we are now going to transmit multimedia from one host to another. In our case, we are going to do it from H1 to H2. For this, we open VLC using the corresponding external terminal of the hosts. Now the correspond the VLC media player which you can see now is of host 2. Hence, it should be configured to receive the multimedia. For this, we go to open network stream, and this is the IP address and the port of the corresponding host, and we have mentioned this. And if we play, it will listen to the corresponding port. Now, the VLC media player, which is now in front of you, this one is of host 1. Now, this should be configured to send the multimedia. So, we add a stock video as follows. We use RTP protocol for transmission, and here we mention the IP address of host 2. As you can see, the video has been started, and for comparison purposes, the two videos are shown here. As you can see, on the left hand side is the multimedia which is received by the host H2. We can see that there is a significant delay between the two multimedia streams. Our QoS solution is better at transmitting multimedia packets. We now move our custom REST router Python file to the Python file which is already present in the RU library. So that the next time RU manager is executed, it uses our custom written Python file. For this, we have to first find the location of the original REST router Python file as follows. As you can see, it is at this location. Now we have to execute a simple move command. As you can see, it has been moved, and now we have to follow the same procedure from the beginning, that is from setting up the mininet network up till the opening of VLC. Setting up the network using mininet, configuring the switches, routers as mentioned before, and by generating artificial traffic using the same parameters of Ostnato. Let us see now how the multimedia packets are transmitted from host 1 to host 2. Again, we open VLC from both the hosts and follow the same procedure. Now, as you can see, for comparison, left one is the multimedia which is received by host 2, and the right one is the source host. As you can see, there is very minimal delay between both the multimedia streams, and the delay has been reduced significantly.